Whoops, I was supposed to stop, but that's not going to happen to you because we're going to go through the entire brake system today on Tech Garage. Welcome to Tech Garage, presented by Advance Auto Parts. Now, we didn't stop too well out there, but that's not going to happen to you after this episode. We're going to take you through brakes from the front of the car to the rear of the car. We're also going to talk about wheel bearings and wheels that are associated with the brake system. Now, we have to start out with the basics though. We're probably pretty confident when it comes to brake components, but you know, a little review will never hurt. So let's start right here with disc brakes. This is a disc brake system. Why? Because this is a disc brake rotor right here. This is the actual caliper, this is the spindle, and the pads are mounted right here. Everything mounts on the front. Now you could have a drum brake system. Now my drum brake system, it's pretty simple. You have a drum out here. What you have in here are some shoes. These are called brake shoes. The wheel cylinder's located right here. Then we move up to the power booster. Now a power booster helps the driver with power assist. How does it do it? Well, there's some vacuum here. It can be a vacuum suspended booster. What happens is I'm pulling engine vacuum on one side, and on this side I'm not. So think about it. When I hit the brakes, that vacuum's gonna move it over and help with the driver assist. Now the last component on this board is the master cylinder, and that's the heart of the system. The master cylinder develops that hydraulic pressure to send down to these wheel brakes. Cars usually have two different types of systems. You can have a front-rear split, which means one channel is going to the front wheels, the other channel is going to the rear wheels. Or you can have a diagonally split system. That means one channel is going to the right front, the other is going to the left rear, or the left front, right rear. But either way, it develops the hydraulic fluid that sends down to either the caliper or the wheel cylinder to activate the brakes. Now we need a couple more basics. If you come down here with me, there's a term I want to show you, and that's coefficient of friction. Sounds like a pretty big term, but it's pretty simple. Coefficient of friction is two materials rubbed together. It's going to be a number. What we get here is a piece of sandpaper. So if I take a piece of sandpaper and I drag it across this table, it's really hard to push across the table. In turn, if I take this ice, it slides right across. What's happening here is we want a high coefficient of friction on our brake system. In order to get a high coefficient of friction, we're going to have the pads mating with the rotors really well, the stopping surfaces. We want to make sure the rotor surfaces are cut right, the drums are cut right. We want to make sure our pads are in good shape. There's a lot to it because brakes have to dissipate the heat. It turns the kinetic energy that's spinning into heat energy. Heat is a big enemy of the brake system. So what we see here is going to put into practice when we get on the car, but the first thing we need to look at is the disc systems.
Normal brake operating temperatures are in the range of 150 to 300 degrees Celsius, but brakes must be able to function at unusual temperatures of 800 degrees Celsius under heavy loads.
Now we're over at the disc at our 2014 Camaro. Now you may have said to yourself or heard, I don't want to work on that new technology. Well, take a look. It's been the same for years. We actually got the caliper right here. It's a floating caliper and the disc. Nothing's changed. Our hydraulics are going into the caliper. Everything's the same as it's been for years. Now come on over here and I'll show you how they actually work. Calipers can come in several different designs. The first one here is a fixed caliper. That means that it's bolted up. When the driver pushes the pedal, it's actually going to move both pistons out, sandwich the rotor, and do the stopping. Our next one here, these two are called moving calipers. One's a floating and one's a sliding. Our Camaro here has a floating caliper. What happens is you push the piston out, the pad contacts the rotor, and the whole caliper moves. It moves on these slides right here as it goes back and forth. The front pad's gonna contact, and then the other one is. This is a moving caliper. Now you can have a floating one, or you can have a sliding caliper. Our sliding caliper just moves back and forth on slides versus the pins, these slides right here, as it moves forward and it moves back. But it's gonna contact the rotor the same way. The piston moves out, slides, both pads squeeze the rotor. Now the last one we need to put a little attention to here is our rear calipers. If you have rear calipers with an integral parking brake here, beware. Some of them have to be turned back in and pushed at the same time. You're gonna have to go get a special tool. You know, you can go down to a parts store like Advance and pick up one of these tools. You turn and you push. If you don't, you're gonna do damage to that caliper. Now you wanna go out and get some Ultra Lube. It's very important, and we'll see that later when we're doing the actual brake work, to make sure that these slides move. If these slides don't move, you're gonna have premature inboard pad wear because it's not allowing the outboard pad to contact the rotor. Now that you understand the basics when it comes to disc brakes, we need to get over to the Camaro and perform some brake service, and we'll do that when we come back.
We'll be right back with more Tech Garage, presented by Advance Auto Parts. This edition of Tech Garage is being brought to you by Advance Auto Parts. Let's get you back to the garage. GRI Engineering and Development, manufacturers of CarQuest Wherever Platinum Professional Brake Pads. ARP, the world leader in fastener technology. And by Race Gas, get more out of your engine.
Welcome back to Tech Garage, presented by Advance Auto Parts. Now, we all probably felt that pedal pulsation. When you put that brake pedal on and it kicks back at your foot a little bit, well, I'm going to show you two things that you can check to solve that problem. The first one is lateral run-out. Now, lateral run-out is when the rotor's warped. It's doing this number, and when it's doing that number, it's pushing on the brakes, pushing on the caliper, sending the brake fluid back up, and you feel it in the pedal. The first check we need to make, though, is called lateral run-out. Now, lateral run-out, I have a dial indicator set up here, going down to the rotor and actually on the rotor surface. Now, our rotor actually has a bolt that secures it, but if you don't have this, you need to put a lug nut on there to make sure everything's tight and secure. Then what we're going to do is we're simply going to go around and spin the rotor. And you can see the dial move. If you have anything more than 0.003 of run out, that's going to cause pedal pulsation. You'll feel that. Now another one, if you come over here with me, I'll show you. This one's called thickness variation, or sometimes called parallelism. Now what I'm going to do is I'm going to take this rotor and I'm going to put it up on its side, and you can take a brake micrometer and you can simply go to 8 different places about the same depth around the rotor. And what you don't want is any thickness variation any more than 5/10,000ths. That's less than 1,000ths. Well, you can have lateral run out and no thickness variation. Thickness variation is where the rotor goes in and out like this. So you need to make both checks, and that usually causes the pedal pulsation. Now, just as important is the discard thickness. Now the discard thickness is stamped somewhere on the rotor. This one happens to be right here. Minimum thickness. When that rotor falls below that thickness, throw it away. It's not safe. That's it. It can't dissipate the heat anymore. So you have to get rid of the rotor. And you can see this one here. We actually had a customer drive into Tech Garage with this rotor. I don't know how they stopped, but this one's definitely not going to do the job. Now we need to look at some pads next. Well, we're good with the disc brake system minus the pads. So we need to look at all these different pads, and there's a lot of selections here. So we brought in an expert. This is Joe from GRI Engineering. Joe, I'm glad you're here because there's all types of pads. Maybe the first question should be, what's the difference in the pads?
Well, John, it's a great question. We have 3 different types of brake pads up here. We've got an organic set, we've got a semi-metallic set, and we've got a ceramic set. The difference is you're going to have an organic set is basically contains no steel fibers. It's more of resins and binders and fibers. Sometimes you'll even find peanuts in there, peanut shells in there, all kinds of crazy things. When you move to a semi-metallic, you're talking about steel fibers in there. You're talking about, again, resins, but it's mainly steel material in there. A little bit more abrasive, harder material. And then when you move to a ceramic, you're talking about copper, brass, aluminum, all soft, non-ferrous materials, stuff that's a little easier on the rotor, also doesn't create a stain on your wheels. You don't get that staining like you would with a semi-metallic version. And ceramic is typically meant for just your average driver, not meant for towing and hauling. You want to move back to a semi-metallic if you're looking to do some towing and hauling.
So it transfers heat better?
It does. If you compare a semi-metallic to a ceramic, I like to use the coffee cup analogy, which is if you use a semi-metallic as a semi-metallic coffee cup and a ceramic brake pad as a ceramic coffee cup, you pour coffee into both. You put your hands on those. You're going to probably burn your hand with the semi-metallic version. It transfers that heat pretty quickly. The ceramic tends to be able to retain that heat, but that can be a problem for the ceramic brake pad, because that actually reflects heat back into the rotor, and you can get it become heat soaked, which would cause you to have brake fade.
I see.
In that case, you would want to revert back to a semi-metallic if you're doing a lot of towing and hauling.
Tell me about these plates on the back of them.
So what we call these plates on the back, these are actually called shims. Some people call them hardware, but in the brake industry, we actually call them a shim. You'll find different types of shims. Some will be steel, some will be steel with rubber, some will be steel with rubber and adhesive. So the more layers you typically have on a shim, typically it's quieter. You're going to find that rubber, that adhesive that we put on there, it actually helps to decouple or dampen the vibration, which is what actually causes the noise. If you have a brake pad that's a clip-on style shim, just want to make sure that it's on there securely so it doesn't come loose and rattle around, and that could also cause brake noise for you.
Well, that's a huge amount of information. Thank you so much. Well, we got the disc brakes done, and now we got the actual pads done. So we'll be right back with more Tech Garage right after this.
Here's a Tech Garage pop quiz. After servicing disc brakes, what should you do before the test drive? A. Apply the parking brake. B. Pump the brake pedal. C. Bleed the system. Or D. Resurface the rotors. The correct answer is B. Pumping the pedal will move the pads into contact with the rotors.
Welcome back to Tech Garage. Now we took our Camaro out and we brought in our pickup truck because our pickup truck has drum brakes. Let's take a look at two types of drum brakes. The first one I want to show you is right here. This is called a leading trailing drum brake system, and it has the shoes right here. It's got a big spring that goes along the bottom. It's got the adjusters right here and the wheel cylinders located right here. Now it's leading trailing because the anchor's on the bottom and the wheel cylinders at the top. Shoes are about the same length. What's going on here? Well, when the brakes are applied, it's called a wedging effect. It gets caught up in the drum. When it gets caught up in the drum, the heat then transfers into the drum, out of the drum, and we stop the vehicle. Now come over here and I'll show you our other one. This one's called dual servo brake systems, a little bit different. Sometimes they're called Bendix brake systems, but what we have right here is you got a primary shoe, which is smaller than the secondary shoe. And that's important because the primary shoe always goes to the front of the vehicle. Secondary shoe is going to do most of the stopping, and I'll show you why. What happens is when you apply the brake, the wheel cylinder comes out. When the wheel cylinder comes out, the primary shoe is going to contact the drum. And when it contacts the drum, it spins around, transfers the energy through the star adjuster over to the secondary shoe. And then the secondary shoe gets wedged in the drum and does most of the stopping. Now, same components. You got shoes right here. You got the wheel cylinder, but you notice the anchor's at the top. On the leading trailing, it was at the bottom. You got associated springs and hardware and our star adjusters right down here. Also, we have a drum. Now on my drum, we have a discard thickness. Once again, 9 inches, 598 thousandths. Drums get bigger, rotors get smaller. So if this drum starts getting above those specifications, you need to throw it out because it can't transfer any heat anymore. Now that's a good look at two different types of drum brake systems. I'll show you some tips on servicing them.
Here are some of the advantages of drum brakes.
Now you all probably serviced rears before, and if you have, you know what a hassle it is. There's all kinds of springs under tension, little hardware clips, but we'll give you some ins and outs that may help. But before we do any brake service, I highly recommend you get a pair of safety glasses because these springs here are under tension. Mine have safety lenses inside, so I'm fine. One other thing is take out your cell phone. Everybody has a cell phone, or get yourself a camera and take a picture of the other side because there's so much going on here. If I took it all down, I really didn't remember where it went back together, I'll have the picture to reference. Now there's two types of service. We can take this all apart, replace the brake shoes themselves, Or you may just want to do a service on them, just clean them up and adjust them. Now, one of the causes of a low brake pedal are the rears are misadjusted. The front does about 60% of the braking and the rear doesn't do too much, so they're not going to wear out as much. So you can just get you some brake clean up all the shoes, clean up all the associated hardware, lube a couple spots here on the backing plate, adjust them up, and your pedal will come up a lot. But if you were to service it, what you need to do is go ahead and get you some tools. This one here's brake spring tool, and this is almost essential, and I'll show you why. The spring's under a lot of pressure. So if I was to take this spring off here, I could hook it, pull it, and pop it off. Now, to put it back on, I just flip the tool around the other side. That's a pretty far stretch, so what I want to do is come on here and pull it all the way till it pops back on. These springs all work the same way. So that brake spring is a good tool. And then I also have a brake spring compressor. You can use this on both of these, pull these off the pin, and your shoes will come right down. Also, you may have a tool like this, brake spring pliers. Does the same job, just flip it around the other way. And while you're in there, you might as well go ahead and replace some of these springs. You can get this spring replacement kit right here. It comes with all the different springs, associated hardware, because there's a lot of heat in these drum brakes. And after a while, they're going to temper.
Here are some of the items John mentioned and their price range. We'll be right back with more Tech Garage, presented by Advance Auto Parts. This edition of Tech Garage is being brought to you by Advance Auto Parts. Let's get you back to the garage. GRI Engineering and Development, manufacturers of CarQuest Wherever Platinum Professional Brake Pads. Stage 8, the world's best locking fastener. And by Custom Auto Sound, the originator of classic car OEM fit radio since 1977. And now the email question of the week, presented by Advance Auto Parts.
John, we've got an email question here from one of our viewers in Lansing, Michigan. Dustin has a brake problem. When he attempts to hold the brake pedal, it fades all the way down to the floor. His buddy says it could be leaking brake fluid, but he never has seen any evidence of that under the vehicle, and he hasn't had to top off the brake fluid. Dustin did replace the pads, but it still does the exact same thing. Today's vehicle brake systems are obviously complex, to say the least. What do you think might be the problem?
Brian, that's another great question from the Advance Auto Parts email. You know, what's happening to Dustin has happened to quite a few people. There may not be any external leaks, but the master cylinder could be bleeding by internally. And let me show you why. What goes on inside of a master cylinder? You have a primary piston and a secondary piston. So what's happening is we have brake fluid in these chambers right here. And when the brake fluid goes into these chambers, you push it in. I told you earlier there was 2 separate channels. Just divide it right down the middle here. So I pressurize this, would be a high pressure chamber, and this would be a low pressure chamber. High pressure chamber, low pressure chamber. This is the secondary piston and the primary piston. So what's happening is he pushes the pedal down, these seals right here, these 2 primary seals are leaking, and they're leaking by internally. So the pedals slowly drop into the floor. Now, you also can have an external leak coming out of the back of the master cylinder. That would be the primary piston, secondary seal leaking, but you would see that one. We also need to talk a little bit about brake fluid, because brake fluids come in different shapes and sizes. Brake fluid is hygroscopic, and what that means, it absorbs water. So if any water gets into brake fluid, it's going to lower the boiling point. And that's the difference between .3, .5, and .5.1 brake fluids is the boiling point. It's going to raise up. .3, .4, and .5.1 are glycol based. So they're used in most vehicles. The only one that's different is the .5. That's silicone based. So make sure you check your owner's manual for the brake fluid you need.
If you have a question for Tech Garage, email it to techgarage@advance-auto.com, and be sure to watch to see if your question makes it on the show.
We have a couple more items to look at. One of them is anti-lock braking systems, and the other are hubs. Now let's take a look at our truck here. This one has a sealed wheel bearing. A sealed wheel bearing, and the hub is hubless because it goes right over top of it. And I have a couple of sealed wheel bearings for you to look at right here at the table. Now this sealed wheel bearing bolts to the spindle. And then what happens, the tire bolts to here, and it spins around. Now there's a couple of classic symptoms. Maybe you're going down the road and you hear a roaring noise, turn to the right or to the left and it varies a little bit. That's probably because your sealed wheel bearing's starting to wear out. Another thing you can do, if you don't know if it's a tire noise or a bearing, change road surfaces. If the noise changes, it's a tire. If the noise doesn't change, it's in your bearing here. Now these wear out over time. Matter of fact, this one I think made a little bit too much noise. This one's totally gone. Now you could have a hub rotor here, and what a hub rotor is, it takes the bearings, and the bearings look like this. They sit inside there, supports the vehicle weights. There's a race and a bearing. If you have this type, you're probably going to have to go ahead and start packing the bearings, make sure that they're fully packed and everything's good every time you take one of these rotors off. Now the interesting part about these sealed wheel bearings and rotors is they have these little sensors built in. This is an ABS sensor, anti-lock braking sensor. What this does is it watches that rotational speed of the wheel and it reports back to the computer. This one here has a tooth ring. It does the same thing, and I can actually show you that right over here on the board. My ABS board has all these wheel speed sensors, and what's happening if I turn it on, you'll see the wheel speed sensors are spinning. So what's going on is it's reporting to the ABS sensor an AC signal that goes to the computer, and then the computer can decide if all the wheels are going at the same speed. If you hit the brakes and all of a sudden one of these wheels start coming to a stop like that one, what's going to happen is the computer is going to do one of three things. He's going to take the ABS module and he's going to pressure hold, pressure increase, or pressure decrease the fluid. So he's in essence controlling the brakes. Here's what's going on. If I take the piston and I run it up like this, the motor can run it up, that increases pressure. If I run it down, it's decreasing pressure. Well, think about it. If I take pressure out of that caliper, it allows the wheel to spin free. If I put pressure into that caliper, it's going to lock up those brakes again till I get that wheel spinning just at the right time. Now, it does it through various different methods. It can do it with direct sensors. There's 3 channels, there's 4 channels. It gets real complex. This is another look at an actual solenoid or a module. Now, we took brakes from top to bottom. We looked at master cylinders, disc brakes, drum brakes. We covered it all, hubs and ABS. So from our garage to your garage, thanks for watching Tech Garage, presented by Advanced Auto Parts.